Assalamu alaikum. My name is Behzti Munfarid Akash. Welcome to my presentation. So at first I wanna thank you my course teacher Nafiz Ahmed Chisti sir to giving me this opportunity. I wanna present about my DLC Obe assignment. The assignment I have already solved, and I wanna give a presentation about how can I solve it. So at first I want to clarify one thing, that I am very weak to understand everyone, the every topic. So if you have any confusion, please comment down in the video. Then I will make another video with a proper explanation. So let's get started. So as you know, you have shown there is a two window. So one window is for the manual we have given, and one is this big window is for the solution I have the solution I am solved. Okay, so here is my ID. So my ID is 235018881. So in this assignment we have seen that the digit were divided into some alphabetical order. So in my alphabetical order, my D was 0. So as a result my D was 0. So that's why my there is a rule that no value can be 0. That's why it was replaced by A, B, H. So my A was 2, B was 3, and H was 1. So that's why it makes 6. So my D was 6. So here is the maximum capacity rule, that it will be BFH. So my B is 3, and F is 8, and H is 1. So my maximum car capacity is 12 cars. So at first the first question, we have to the initial stage, we have to develop a block diagram for a designing automated car control system as described above. So in this figure we wanna see that a keypad, and a keypad gives a input. That input go to the encoder, that could register, that could go to the comparator, then it will be go to the register, then it will count the parking space, then it will go to the clock, then the timer IC shows that the space was available. If space was available, then the display shows that space is available, and if there is no space for the car, then the display shows full. So I build a flowchart or a block diagram for the sensor. So we have seen that the sensor will sense the we have a two sensor, that one is NT sensor and is exit sensor. So NT sensor count the data of the gari was entry, and exit sensor was taking the data of exiting. So both are connected in the up counter, then up counter to decoder to comparator. If the comparator compares, the value is equals to equal. So the timer IC will be configured as monostable full, and display will be show full. And we have another case, if the comparator compares the value is less than 9, so then our timer IC, any T5 timer IC will be acts like a stable mode. So it will print in the screen that space available, and display that parking is available. So in the in this question, so we have to instruct, we have a give instruction to make a flowchart. So flowchart that we'll start it with initial is the counter as a 0, because we have initial point is 0. Then we have to check the every sensor, we have to check the every entry sensor, we have to check the every exit sensor, we have to update the counter. Then the counter is equals to 0 0, then the condition is yes, so display will show full. If is no, then the blink display will show space is available, and the repeat, so that can loop in the loop, the process began by loop. So here is a, in my id count, the count was 12, so that's why I need a 4-bit counter. So I make a 4-bit counter. So as a entry, I use the coefficient of 1. As a exit, I use a coefficient of 0. So there is a 0 0, and there is a arrow, and this arrow is goes for down count, and this arrow goes for up count. And we have used JK flip-flop transistor table. So here is the table. So we have a Q1 and Q1 plus, and there is a flip-flop J and K table. So we have built a 4-bit up counter. So this is up counter. So we have a 4 coefficient, so that QA, QB, QC, QD, and we have a QA plus 1, B plus 1, C plus 1, D plus 1, J naught, J naught, K naught, JK, JK1, JK2, JK3, so JK2, J3, K3. So we have built a truth table, that, and in the truth table we have solved by using K-map, that we will consider the where is 1. So in the J1 we consider this value that we have taken, that if there is a 1, so we take the K-map from the value. So after solving the K-map, we get the all the values of the from the truth table. So here the truth table, then we will implement to the table. We will implement to the table. So we will consider it at ff3, ff2, ff1, and ff0. So we have connected to the JK flip-flop counter to it. Then we have to draw a 4-bit counter. So as a result, this will be QA, QB, QC, QD. Then we will use a as a prime, QA prime, QB prime, QC prime, QD prime, JA, KA, JB, KB, JC, KC, JD, KD. So this is the truth table I was plotted. So in this truth table, I have also doing K-map to extract the value from JA, KA, JB, KB from it. So then I have the connection diagram, what the circuit looks like. Okay, so next I will go to my second question, the design a circuit to activate 7 to 7 segment display, 2 555 timer IC, one circuit to display full and another circuit to display space available. So here is my so I have a 2 display. So there is a first display for I have to configure my 555 timer as a monostable mode. So monostable for counting gate if space is available and is stable for the 7 segment display. So I am using a stable and monostable a timer IC together. This is my timer IC and this is the timer IC pin diagram. So we have know that the real IC has some 8 pins. So there is my 8 pins. So this is my first timer IC and this is my display. So there is a connection. So we have R1, R2 and R1. That value we have taken from to the calculation from the data we have. So here is the connection and this is the stable mode and this is the monostable mode. So this stable mode will show that this will be full and this monostable mode show that this will be light blinking. Okay, So going to the derived values. So we have to derive the value because the R1 and R2 was unknown to us. So if the circuit running, we have to determine the R1 values. So after the R1 values, we have to go to the first page. The first page, we have determined the maximum parking capacity was 12 cars. So we have to calculate the P. So in this there is a equation of P. So P is equals to A B D E G plus into 2. So I have gotten the value of 44. Then we have a frequency equation. So frequency is AC. So my AC was 255. So that will be 12 hertz. And my T was 1 by F. So 1 by 12 is equals to 33.33 ms, and my duty cycle was 100 minus P. So my P was 44 that I have been collected from it, so that will be 56%. My duty cycle was, the formula was TH plus T only T. So here is my 100 TL, sorry, this TL. So this is caused by 100 and this is by 100%, and this is H, so that is for 56 ms. And in the TL we have to minus the T from TH. So T we have no, it is already 100, and TH is 54, so it will be come from 44 hertz. 44 hertz. So slightly I have mistaken it. TH will be 56. Sorry guys, T6 will be 56. I have done a unintentionally mistake that sorry, T6 will be, sorry guys, I have make a unintentionally mistake. So it will be, so it, okay, one second to connect my mouse to solve it. Okay, so I'm really sorry for that. I have make a multiplying mistake that it will be 56. So it will be 56. Okay, so it will be 56, and it is then now it will be 44 ms. Okay, so so in this in the question we have instruction that we can choose a capacitor value. So we have choose a capacitor value of 200 microfarad. So 200 microfarad, we have to calculate the TH. So TH has a default value that 0.61 plus R1 plus R2, and TL was 0.693 R2 into C. So that's why by the solving the equation we have calculated our R2, that was 211 ohms, and R1 is 57 ohm. By to solving those values R1 and R2, we put it the R1 and R2 in it. Okay, so our second part was done. So third part was the vaccine design. So this is the most difficult topic I have faced. That's why I have also beaten it. So if any confusion that related any question, please comment down below. I will make a explanation video later. So prepare an FSM design output for AATH and BTLMH. So in 2 number question we have got our TH was 54 ms and TL was 44 ms, and that has a condition that it can be less than greater, it will be always that 4, that the value will be always greater than 4. Okay, so we're using 2 states for FSM design. So was S0 and S1. So for the S0, A1 and B0 stays for 4 clock cycle, and for S1, A0 and B1 that stays for 4 clock cycle, more there will be toggle in every 4 cycle. So we have to the state table. In the state table we have a current table that S0 and S1. So the counter value will be 0 1 2 3 0 1 2 3 and 0 0 0 S1 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 S0. So 1 0 1, so the output will be 1 0 1 0 1 0 1 0 0 1 0 1 0 1 0 1. Okay, and we have the state diagram. The state diagram we have shown that the output is will be 1, A is equals to 1 and B is equals to 0. The condition is count will be less than 3. Then we have to go to the S1, the selection pin 1, so output will be A0 and B1, count will be 3. Here in the first state, it will be the higher for 4 ms, that will be become low for 4 ms afterward. Again it will be second state B for high for a 4 second, the turn will be low for a 4 ms. And we have to write the implementation of the VHDL code. So at first we will module, we selected the FSM blink, we input the clock, reset, output, register, we have a register, so AB, so a register we have to go count the 1 is to 0, and we have to the registered, and always pass is edge clock for the post edge reset begin. If RST begin, count will be 0, state will be equal than 0, and state count will be equal than 0, state will be equal than 0. So A will be equal than 1 and B is equal than 0. Else we have make a loop so that it will begin, and the count is also be less than count plus 1. If count is equals to 3, then it will be begin, the count will be greater than 0, less than greater than 0, and the state will be greater than state end, and the state will be again 0, then it will begin. So sorry, I made a mistake that the sign is the greater than, not less than. If the previous I tell less than, so I apologize, that will be greater than. In my mistake that I can't see the opposite. So then I will make again a run a loop, so the loop is equals to 0, then it will begin a greater than 1, b greater than 0, then end the a, we will end the loop, then we will begin another a is less than greater than 0, and b is greater than 1. So there is an end, and in module we have to end the program. So for the last the topic was identify the drawback or limitation for the part 1 and 2, what the modification can made to the system empty in the parking space with a higher number of car current in the car set, analyze the impact the specimen. So we have some drawback in our limitation. The first drawback is as the design, the ID limit was 12, so 12 is a pretty small parking size, so it means it can hold max 12 cars. So based on the 4-bit counter used, the design cannot be adjusted dynamically because the duty cycle and frequency at the blinking display are fixed register, and capacitor used in the 555 timer circuit. A single entry and exit is effective for small lots but won't function well thus several gates. Basic screen mean it doesn't indicate full number of space available if only full or space available. So in the summary we can say that we can easily control the parking system by 4-bit counter if the capacity was 12 cars, but if the capacity increases, so we have to improve our bit counter. So that was a very drawback. So we can, how can we improve, we can, how can we make it better? So using a microcontroller. So microcontroller is a very popular things. So we can make the parking system more automation and more smarter and easier to control and space count. And we can install a spot sensor that will be more precise and the more improved the driver resistance. Install the sensor in every area and improve the display. If we improve the display, the we can show also many things in the display, and we can link it with a online or IoT things that people can reserved a parking spot for a time or a they can see the real parking location or the security system by remotely. So thank you. I know that I have somewhere I have some mistakes, so I accept some uh, consideration to you, sir. So if any question, please comment down below, and thank you for watching this video.